Okay, guys, thanks for coming back and watching this year 12. This is a special video that I wanted to do for annuities, both present, future, and perpetuity. I can never say that word. Perpetuity. Anyway, this video we're going to be explaining the fundamentals of it through three kind of very basic and easy questions before we just go straight to the worked examples. So this is kind of like a bit of extra bonus content that I wanted to do. So the first question we're going to look at is Jim sets up an annuity. I'll just move this down so it's away from the headings. Jim sets up an annuity depositing $10,000 at the end of each year for a total of 20 years at a rate of 6.5% per annum, compounding annually so he can retire. Calculate the future value of his annuity. So the first thing I want to talk about is, let's go through this the previous way we've done it. And that's actually just setting it up with a table and different lots of compound interest. Now, the first thing I've done that you're about to see is we're just going to compare it all to a table here. So let's start filling this out. So here I've got time, and this time is going to be in years. Okay, make this a little bit wider. So here he deposits 10,000 at the end of each year for 20 years. So 20 years. Okay. What we've got is a cumulative deposit as well. Sorry about that. Okay, so what we've got is a cumulative deposit as well. So let me just highlight this and we'll talk about what it means. Now, every year, as I said, he is going to be depositing money at the end of each year. Okay, so for the first year, for argument's sake, he's only going to have $10,000 because it's at the end of every year. Okay, so no interest earned, but he does have 10 grand at the end of the first year. Now, when we get to the end of the second year, yes, he's going to be making a deposit of $10,000, which is what we're seeing in this little section up here. Okay, but he's also earning interest, 6.5% to be exact, on the previous amount. So what that's going to do is it's going to give us a little bit more, a little bit more than $20,000. So you can see here, he's deposited 20, but now the interest is starting to kick in. Okay, so what I'm going to do is just unhighlight half of these, and let's see the effect that it has on it. Okay, so we can see we've gone from 650 to nearly 2,000, 4,000. Okay, it's actually growing at quite a large rate. All right. Now, eventually when we get to the bottom, like if you have a look here at year 13, he's nearly hit that $200,000 mark, how much he would have had if he, say, buried his money in the back of the yard or something like that. Now, eventually we get to the point of $388,253.09. Okay, so that's how the annuity works. Now, the reason I wanted to show you this, okay, and we've done this is nothing new, okay, this is where we used our recurrence relation to generate this, is we're going to now graph this, and I'm going to explain how this annuity works, say, on a graph setting. Not just that, but we're going to actually look at the formula for the future value of an annuity, and I will talk you through how it works in just a moment. But first, if we have a look at the annuity here, okay, I'm just going to zoom in quite a lot, and I want to show you what actually happens. Excel isn't generally nice when it comes to these kind of graphs. I have to show you. So in this circumstance, just get a pen, make sure I'm using the black font. What's actually happening is here, he's just going along the base. After 1 year, he makes the initial deposit of $10,000. Now, from there, this is where interest will start building. Okay, 650 to be exact. Curves up a little bit. Another 10,000 deposit. So it actually curves up, and then you get a little step, if you will. Okay, I know this is really hard to do. I do apologize, guys, with a mouse. But effectively, you get these little incremental increases and small amounts of compound interest in between as they go up. All right, and eventually, as you get higher and higher, I'll just quickly erase these. As you get higher and higher, grade 12, you'll approach an exponential rate. So you can see here how high it ends up getting to. That 388,000. Now, what we've got here is the, oops, sorry, we'll zoom out. I know you can't see all of that. Just going to quickly check that this doesn't cut anything off. Yep, we're good. So here we've got the future value formula. Yep, no, we're still good. We're not cutting anything off. Awesome. So we've got the future value formula here, and I'm going to talk you through it. Okay. So get my highlighter out, and we'll go with yellow. First thing we need to do is we need to find those regular payments. Let me just make that pen size a bit bigger. Oh, a little too big. But we'll erase this first. Go back to the highlighter. There we go. That's better. So I've got M. Okay, so this is my formula. Now, what I've actually done, if you want to just look here for a moment, I'll make this visible in black. I've actually used that formula, subbed all the values in, and got my answer of $388,253.09. Okay, I've actually gone through and done it already. Now, this is the formula, okay? The Excel formula I've used is up here. There's my M value, 10,000. We're multiplying it, and now we go on to the next part. So the next part I want to look at, okay, is this 1 plus I. And I've done that just here. Now notice I didn't need to do anything special to the 0.065 or the 6.5%. Because it compounds annually, you're just dividing it by 1. 0.065 divided by 1 is 0.065. So it stays as is. Next section, we're going to look at that n value. Okay, so the little n here, and that's where the 20 is. Okay, it's over 20 years, so it's to the power of 20. I've then gone, let me just get the eraser. I've then gone and subtracted the 1. Okay, you can see that there. There's the subtraction by 1. Then what we need to do is, eraser's not working, there we go. Then we divide by I. Again, I've already established why that I value here is 0.065, why we didn't need to divide it by anything. Okay, pretty straightforward. And when we hit enter on that, this is the answer we get. Now, notice this number equals the number that we got back here. All right, you see that cell? We did it the long way, and we got the same number as using this formula here. All right, we'll do some harder examples a little bit later as well. Now, some of you might be thinking, okay, but surely this also has what's known as present value. And I'm going to talk about this second formula now and what that present value means, because it has, I guess you could say, two meanings. Now, one of those meanings we're going to go through a whole nother question, but for now, I'm going to talk about what a present value means. Now, in this circumstance, and I'll get my pen out for a second, this is what we know as long-term planning, okay? In this case, Jim invested 10 grand every year until eventually he got until this point, okay? This is how superannuation works. Very straightforward. Now, in some cases, some people prefer to do this as a lump sum up front. Now, I know that might sound silly, but just as an example, let's say when you were born, okay, your parents might have gone to an expert and say, how much do we expect university to cost when my son or daughter reaches the age of, say, 18? I want to set up a fund now that will compound and basically provide education for them. Now, they could set up an annuity just like Jim has done here. There is nothing stopping them doing that, okay? But what they've said is they want to basically just kind of fire and forget. They want to put one lump sum of money in a bank account and watch it grow. Now, obviously, in the real world, you know, rates vary and different things like that. But for these questions, we're going to assume that it stays constant. Now, as I just draw on the graph here and how it kind of zigzags up and down, kind of like steps with this, what we can do is we could actually find, and this is just an approximation, we could actually use this formula to find that present value. Okay, so if we were to invest it at a steady compound rate, okay, it would grow to the exact same mark. And that's what we call the present value of an annuity. This point right here. Okay, now using this formula below, okay, I'll go through and do that now. Just erase this. So, what I've got here is all of the values substituted in. So, again, I'll highlight and show you how I substituted as I go. Let's make this a little bigger. This should work. Oh, it's gone that color. Sorry for this. There we go. All right, so first off, we've got M. That still hasn't changed. That's still 10,000. Okay? Notice my use of brackets as well, okay? This one can get quite complicated. All right? Only through practice will we get there. Now let's look at the 1 plus I. That's still there. 1 plus 0.065 is 1.065. Nice and easy there. Okay, nothing new. The power of 20 is still there. The minus 1 is still there. Okay, what's new is we've got I times, so the 0.065 is there. I'll use a different color actually. 1 plus I, we've got the 1.065 there. And finally, to the power of 20, there it is. So that's all been put into our Excel formula. Okay, and if I just go through and double check it now, all right, make this text black, we get a value of $110,000, 110,185 dollars. Now, let me just prove to you that this value is what we need. Let's try putting that into our compound interest formula. Okay, so for those who don't remember, our compound interest formula is A equals P times 1 plus I, close brackets, to the power of N. So in this case, we've got $110,185. We'll just round down. We're going to multiply that by 1 plus, it's going to be 0.065. Okay, it's still compounding yearly, hasn't changed. That's going to be all to the power of 20 because it's still over 20 years. Now watch what happens. Oops, forgot the equal sign. That would be good. Notice how these two here are basically the exact same number. Yes, they're about 30 cents off, but that's not a big deal. The $388,000 is seen there, and I'll just turn that into currency now. There we go. That looks a little nicer for us. Okay, so that's what the present value of an annuity means. Okay, if I was to invest a one number lump sum now, forget about it, and it grows at the same rate compared to the annuity, all right, I will end up at the exact same point, all right? If that doesn't make sense, I suggest pausing the video, going back and trying again from when I start talking about present value. If it still doesn't, come and talk to me. Happy to help explain it again. Now, there is a second type of present value, and that's what we're going to talk about now. So we're going to go over to this question. So, Pamela plans on attending art school for 2 years and will not be able to work during this time. Instead, she will set up an annuity that she will withdraw from in order to cover all her expenses while at art school. To do this, she budgets her expenses to be, on average, $2,025 per month. Prince Family Bank offers her a rate of 4.55% per annum, compounding monthly. Calculate the present value of the annuity she will need to afford this. So we have a situation where this person wants to take basically a lump sum and just withdraw $2,025 every single month until eventually they run out of money, but they've achieved their goal. They just want to cover that short period of time while they educate themselves. Now, obviously, we're not assuming any kind of welfare or social security net for them. They're doing this all off their own back. We also assume that these rates, while they are variable in real life, they are going to stay fixed for the term of this annuity. Now, some of you are probably sitting there saying, but so why don't we just take the $2,025, and that's an interesting point. So let's take that $2,025. If she wants to take that much out a month, every month for 2 years, that's over 24 months, why doesn't she just save up $48,600? Okay, now that's very similar to Jim's idea that he had, where, if he just wanted to bury his $10,000 a year in the backyard, he'll have $200,000. But as we saw, that went from $200,000 based on the annuity, it went up to $388,000. So it's all about earning interest, and that's what's going to happen here. Okay, a lot of people often do this when they say going backpacking or different things like that. They work out how much they need to live off of, but that amount that they have will still earn them interest. So again, I've already established that this is over a total of 24 months. Oh, that's the last two. So over a total of 24 months. So I've set the table up to show it to you that way. We've then got a cumulative withdrawal amount. Okay, let me just show you what I mean by that. So at time equals 0, she hasn't withdrawn anything yet because she doesn't need the money. Okay, but at the end of the first month, she's going to withdraw that. All the way at the very end, she's going to withdraw her final amount. Now, this is a running total. We know it's $2,025 every month, and you'll notice that those two match up. Now, for the first one, that's pretty straightforward. Nothing really new there. There's no interest. Where are we? Okay, so that was our starting amount. Now, at the end of the... What's happened here? Sorry, something just kind of awkwardly happened. Let me just try this. I'm just going to quickly display the others. Hopefully it cooperates with me. Yeah, that should just be equal to this one. Not sure what happened there. Sorry about that, guys. Okay, little typo by the looks of it. But anyway, we're back to it now, and I'll explain all of this as I go. Now, this is very much like a recurrence relation. Do we need it? Probably not. Okay, but what we have here... No, it shouldn't be equal to that at all, actually. I realise what I've done. This should be equal to G16 by the looks of it. Has it got... Oh, it's taken away, deleted. Oh, no, here it is. There's my present value amount. Okay, so we've mentioned earlier the $48,600. Okay, and there's obviously a better way to do it. Now, this present value amount will spit out a total of $46,370. Now, I'm just going to quickly explain the purpose of this value, okay, and what it means. It's very similar to a reducing balance loan, but instead of a loan, it's actually an investment that we're constantly withdrawing from. And my graph in a moment will explain that a little bit better. Okay, so with this present value, let me now go and highlight these. Now this should have been equal to this, my apologies. Okay, now at the very start, I've told you that the present value should be 46,370. It doesn't need to be 48,600. She actually needs less money. Now, what we've gone and done through this, as you can see up here, okay, is for our rate, we had to divide it by 12, okay, times it by the starting amount to work out how much interest we earn, and then minus the withdrawal of $2,025. Now, what we found, grade 12, is that after the first month, because Pamela has invested this money, okay, she earned a total of $168.81 for that month, okay? So while she couldn't live off the interest, okay, it gave her that extra source of income without needing to work. Again, why it's very handy for backpackers, all right? Now, as you can see, as the months go on, they're getting lower. Okay, this interest amount is getting smaller and smaller until eventually it bottoms out perfectly, all right? Because that's the whole goal of this present value, in this case of the annuity, all right? It lasts exactly the 24 months or the 2 years. Now, think about the reason that it's getting smaller. If you're not sure, pause the video, have a think about it for a second. If you're still stuck, I'm going to go through it now. So the reason that the interest earned on it is getting smaller and smaller is because, remember, for each of these formulas, notice at the very end of each of them, notice how I'm subtracting $2,025 from my final answer. Okay, the reason I'm doing that is because she needs $2,025 to pay her bills while at art school. Okay, so this is, again, another example of an annuity. And at the end of the 2 years, she runs out of her little kind of slush fund to help support her while she was at art school. Okay, so there's our final answer for that one. Even though it doesn't seem like a lot of money, like she saved, what's that, about $2,230, that's still better than nothing. Okay, by utilizing this bank's interest rate, okay, she was able to save money that way. Okay, and that's another way that we can look at an annuity in this case. All right. Now, if I go to the graph, let me just quickly explain how this would work. Now, this looks like a straight linear equation, but as we spoke about earlier, it's not, okay? There's actually little changes happening here, and let me just zoom right in, and I'll show you what I mean by that. Now, we can't see it here, obviously, but if I were to draw again, let me just make sure I've got the right size. What's actually happening is she's earning her $168 interest up until this point. Then she's withdrawing the $2,025. Okay, then she's earning another just over $100 interest. Then it's dropping down. Notice how it's almost like a little inverse of Jim's example. Okay, now if I were to just quickly go to the very end, you'll see what I mean. Okay, sorry. There we go. So there's the end of our graph over here. What's eventually going to happen is when we get down to like the last payment, all right, she earns a tiny little bit of interest. In fact, it's so low, I think it's only $7. And then she hits her $0 at the end of the 2 years or 24 months. Okay. For example, that last month she only $7.65 interest, okay, compared to the 168 she was getting at the very start, but it's because of those constant withdrawals. Okay. So in other words, if Pam wants to go to art school, okay, and she wants to just live off that kind of one-time investment amount, not assuming no helping hand or anything like that, she would need a total of $46,370. Okay. So that's how a present value worked. We looked at two ways. We looked at the lump sum amount to get to this point, and now we've looked at the example of the annuity where it's almost like a reducing balance, not alone a reducing balance investment, I would call it, okay, because she's constantly making those withdrawals, okay? And of course, you can always rearrange these formulas if it ever asks you, say, what type of payment is needed to hit this mark. Now, finally, we get down to our last question. Now, perpetuity is what we are dealing with here. So Dwight comes from a privileged family and decides he is going to live on a beet farm with his cousin Mose for a break from luxury living. Dwight's parents don't want him to stress about paying any bills or rent while out there, so they established a perpetuity. Sorry, there's a little typo there. So they established a perpetuity. If the bills and rent for Dwight total $203 a week and the bank offers them a rate of 4.93% per annum compounding weekly, how much is needed to invest in this perpetuity? Now, the textbook gives you this formula, A equals M over I, where A is the total amount that we originally invest, M is the amount that you need basically to survive per period, and I is that interest rate per period. Now, looking at the information we have from our question, okay, I'll just get out my little highlighter quickly, get a bigger one. So we've got here, that is kind of our I value. Just erase this. That is kind of our I value. We need to tweak it a little bit, just because of the compounding weekly, but I'll get to that. And here, that's the amount that Dwight needs. So to do that, okay, here's what we do. We go and we're going to start our formula. So we know what the M value is, $203. Now, if you just divided that by an I value of 0.0493, you would be incorrect, okay? If you did it this way, that's assuming that you have an interest rate of 4.93% per week. That is not the case at all. We have a rate of 4.93% per annum. So what we need to do is we need to take this rate and divide it into 52 equal installments. And what that will give me is it'll give me a weekly rate. Now, when I do that, I end up with this answer, $214,117. Okay, rounded, we can call that $214,118. Now, what that means is that's the original amount that Dwight's parents are going to need to invest, so he basically doesn't have to worry about his bills. Now, what do I mean by that? Well, I'm going to talk about it now. So, let's say, for example, you have $214,118, and you say to yourself, hey, I'm going to invest that, all right? I'm going to invest that in the account with the same details here. Now, let's use our compound interest formula, similar to what we did earlier. We know that A is equal to the principal, in this case, $214,118. We're going to times that by 1 plus I. Now, remember, the I value here is not 0.0493. It's 0.0493 divided by 52 because it compounds weekly. Now, we could work out how much we get over the year, but we don't want to do that. Now, why don't we want to do that? Because that $203 is going to be subtracted from our perpetuity every single week, okay? They're the bills that come out through rent and different things like that. So we want to find out basically how much money we get per period. Because it compounds per week, we're just going to put it to the power of 1. Now, to work out just the interest for this amount, we take away the original principal, $214,118. Notice how that gives us $203, and yeah, we're just going to round that to 203, okay? There we go. So what this effectively does, if you were to draw this on a graph. Every single week, you would earn $203 interest and then take it away straight away. And the cycle would repeat, wouldn't it? Over and over again. It's never ending. As long as you keep these same conditions, as long as that $203 doesn't grow any bigger, all right, you will not be making money on this $214,118. Obviously, you'll be using it to pay bills, but you'll never be losing money. Okay, it's used to set up, in this case, Dwight and Moe's paying for their bills while they live on that beet farm. Okay, so that's how perpetuity works. You don't tend to see them too often in the real world these days. Okay, usually we just look at annuities and different things like that. But it's a cool little area of maths to look at. You know, how can we, I guess, have a self-sustaining compound interest line? Okay, and some people do actually do that. You know, if they want to send their son or daughter away and don't want to pay them, you know, millions of dollars, you know, as like a gift or anything like that, they could set up something like this to help them out. You know, give them that money to support themselves. So again, sorry for the jump around a little bit with some of this information. Hopefully this video has helped you see what an annuity is, how they actually work. Okay, I know it might have been a bit rough, but yeah, that's everything I've got for you guys. So we'll go on with some worked examples now, and we'll look at how we can actually use the future value of an annuity and the present value. Okay, thanks for watching.